Hi again. So how did I prepare and compile the sprites with TCC? Unfortunately, I had to find out that I forgot to add the source code of the sprite data in the Tempus package. I'm sorry for that, and so I'm adding the program animation here. It is the one with 111 blocks. Please copy this file animation to your TCC 1.5 disk. There should be more than enough blocks free. I have already prepared this on my disk, and so I can show it here. The disk itself contains the compiler, the help file, which can be called from inside the compiler. Then we see the three libraries, the tutorial files, which we'll not look at today, and then the source code for the demo game. Tempus with 10 koala bitmap files, and you can easily recognize them by the 40 blocks. Animation is the source code with the sprite data, and animation.bin is the compiled version of it. And then we also have the sound editor with the music file wrong, and we will care of that a little bit later. For this video, I decided to use XEMO, which makes it much easier for me to record the video. I have a tip for all those who use the Coffeebreak Compiler within XEMO and not with the MEGA65. The functionality of page up and page down of TCC is controlled with the F9 and F11 keys. As it is in BASIC. However, these two keys have other functions in XEMO, and my tip is TCC is written in BASIC and it is very easy to customize. My suggestion is that you map the page up and page down functionality to other keys. For example, Alt point and Alt comma, as you can find it easily on the PC keyboard. So let's load TCC 1.5. And we will have a look at the lines 400 through 416, which deal with the cursor functionality. There we have the code of the F9 key, namely 16, and which I now set to 1 to 6. And there is the code for the F11 key, namely 22, which I now set to 124, and so done. There is nothing more to do. I'm going to save TCC 1.5x for XEMO and start the compiler. So to load our animation file, it's simple as it can be. You could just type animation, hit enter, then F1, load source, and here it is. So yeah, let's see what the file does. Actually, the file is not very long. It simply includes the library sprites, which I need for the sprite copy command, which is defined in this library. And there are sprite copy routine for our 13 sprites and for the cursor sprites, and then the program is ended. This is all that is the program does. But what is below? There's the definition for each sprite. In TCC, you can see it is done with the sprite command, and then there is the 16 pixels for each of the full color sprite. What we can see also here is a label. A label is a certain point in the in memory to which I can refer from for example a function or for within inline assembler and so on. So what we can see here is oben vorne, which means upper and front, and we can see the 16 pixels of the sprite for the upper body. The dot means the transparent color, and the color values are in actually hex values. So here, for example, it is 9 for the player's brown hair, and it's an A, that is 10 for the pink face. The second parameter of the sprite function is the color value for the transparent color, which is the points in the sprite. Okay, the file has saved the sprite information for all 13 sprites. As you can see here, I'm moving down page by page, and it's here from behind and from the right, and the legs for left and legs for right, and we can see here even the cursor is a sprite. So let's move upwards. Okay, to the beginning of the file. So so now the copy sprite or sprite copy routine does take the data from the position of the label and copies 168 bytes to this position, to this memory position, and this is 16,384 is hex 4000. And as we can see here, the second sprite starts at position 16,576, and this is exactly 192 bytes after it. Only 168 bytes are copied, but we want to keep the width of the slots, otherwise it won't work with the sprite pointers, because as I said earlier, they can only address 64 byte segments. In the comment, I've written a reminder for me of what I have to do with the sprite data. First I have to compile, then execute the program so that the data is copied to location 4000 and up, and then I have to end the compiler and start the monitor and save the range from 4000 to 4A80, which is not actually right. It has to be bank for 4000 to bank for A80 with the monitor's save command, and this is how animation bin is created. Now, just for test purposes, I changed the player's hair from brown to red. This is easily done by changing the nines to 2. You can see here that I simply use the cursor keys from one line to the other. TCC does not need to confirm changes with the return key. It is simply the cursor key, and that is okay. So I make some modifications to the hair color, and this is okay for our little example. So now I compile the file. I simply press F5, and as you can see here, compilation starts. It seems that it is hanging at 1%, and the reason is that the compiler is parsing the sprites library now and compiles it, and this takes some seconds. Now it is done, and now it shows that the compiling is going on. So as we can see here, it is not a very fast compiler, and that is also the reason why I named it the Coffeebreak Compiler, because this is the right moment to go to your coffee machine and make a short coffee break. And when the coffee break is finished, then it might be that also the compiler has finished his task. So the compiler is finished. Now I want to start the program, and as you can see here, it is always executing at the position of the cursor. So the cursor is now at the end of the command, and when I start with F7 at exactly this location, it says the program is done, and it has ended without any errors. Press a key, so everything is done, and now I can end the program with run stop or with the end on the PC keyboard. So the compiler is quit now, but the code itself is not gone. The compiled code, it is saved in bank 4, from which I will save it now to disk. Why is it in bank 4? It's in bank 4 because TCC compiles code always to bank 4 when it runs parallel to TCC in basic in bank 0. You can also have the code compiled to a file, and then it's standalone and can be loaded standalone without TCC, of course. First, as we can see in our directory, there is already an animation bin file inside. So to not get any errors, I will erase it first. And then I go to the monitor, and yes, maybe we can look at the memory there. So let's see memory from bank 4 at the location 4000, and what we can see here is a wonderful example of the first sprite with 168, and you can see the zeros at 40A0 or 40B0, and this is the filled values with zeros between the 168 bytes of sprite data and the 192 byte slot that is starting for the next sprite at 40C0. Okay, so now save animation bin .unit8 bank 4 4000 to bank 4 for A80. So this is done, and this completes this second video. Thank you.